Hi guys, so welcome to the build video for the ImmersionRC XuGong V2 Pro Quadcopter. So anyone who's seen the unboxing video would have recognised most of the parts laid out in front of us. Basically, pretty much everything you see in front of us here is going to be used to build this quadcopter. I'm going to be using DJI E300 kit for ESCs, motors and propellers. I'm going to be using the DJI NAZA V2 with GPS. We've got the PMUv2 here and the LED. For my receiver, in my own little cage here, I've actually got the ImmersionRC EzUHF, which I'm going to be using in PPM mode, so there's only one cable that actually has to go to it. And then for my video transmitter, I'm going to be using an ImmersionRC, surprise surprise, 600mW 5.8 transmitter, all basically purpose built and designed for this frame. So the other parts that we've got in front of us, like I say, if you haven't watched the unboxing video, I go into quite a bit of detail on what we've got. However, basically we've got the fold out arms, the aluminium extruded fold out arms that we've got here. We've then got the actual frame itself, the carbon fibre frame underneath here. We've got the PCB / power distribution. This is actually going to be mounted upside down, I believe, and I have to confess I'm actually doing this without a manual because the manual hasn't been released yet, so I'm going to feel my way, but having built the first one, I would imagine I can probably find my way fairly well. From the images that I've seen, however, this is going to be the top, that's going to actually be the bottom, so we've just got to bear in mind that all the soldering and everything needs to be sorted out beforehand, before we get everything mounted. That's probably going to be a bit fiddly, and obviously I will deal with the soldering and everything in a separate part of this video. Moving on from that, we've then got 4 rubber feet, 1, 2, 3, 4, and we've then got the anti-vibration dampeners here. We've then got the little clips that prevent the anti-vibration dampeners from releasing the frame underneath the arms, so there's no worries there. We've got 4 slightly larger 2.5mm hex bolts. These actually hold the frame to the power distribution board. Then we've got 24 of these little nuts with encapsulation devices, and we've got 24 bolts that go with them. These bolts are using the 2mm hex, so you want to get yourself a 2mm hex, and also you want to have available to you a 2.5mm hex, and that actually will do the larger bolts here onto the frame. You'll also be using the 2.5mm hex, I believe, for the motors and putting them on. So you should have everything covered with just those two hex devices. So the first thing that I would recommend that you do is, number one, count up everything. Like I say, I've got 24 of each of these. And the next thing that I've done is, this is the actual, hopefully this will get in focus. This is what I'm calling a nut encapsulation device, or encapsulator. So you've got a little clip there. You can see there's a flat bottom and a hollow top. So we then take our nylock nut, nylock facing upwards, and all we do is we slide it. Come on. There we go. We slide it into there, and you can see that's now all snug. And I have done that on all 24 of them because you're going to need to do it. You may find that there are some spares, but just have a count up just in case. And obviously if I find this is the wrong number by the end of this video, I will know. I've actually got some spares because I had the original XuGong, and that uses the same format. So with that in mind, that's basically the setup. So we'll get building. The things that I'm going to do first, I'm going to start laying out the frame and where the flight controller is going to be. Okay, so first and foremost what we want to do is get the frame laid out. All we're going to do is we're going to lay out the base, and we're going to put the sidewalls on it so we can see how much space we've got to play with and any little problems. This is the actual base plate here. This is the top part. You can see there's a nice outdent here, there's a nice cutout. That's actually so we can access the flight controller should we need to. There's not a huge amount of space to play with, but put it this way, the original XuGong, this was the amount of space to play with. All you really had this hole for was to pass the cables through it. It made life quite awkward, and it was quite tricky, so it's nice to see at least there's an open space, and the fact it's carbon fibre means that, you know, rigidity and solidity of this should be absolutely fine, and it's going to be nice and lightweight, which is good. Now, one thing that I would say on this, we've got these 4 holes, 1, 2, 3, 4. This is the base. Then what we've got is on our sidewalls here, you've got these little sticky outy tabs, as I'm going to call them. Now what these do, these actually go into the holes, so they go through the holes, so they kind of dig into the feet. Now what I would suggest you do is you grab your feet and you actually pop them through the holes first. Now as always with these, you're going to get used to fiddling around with getting rubber bits through holes, because the anti-vibration things work as well. If you just work them around, what I tend to do is grab a fairly blunt, don't get a sharp screwdriver, I've got a hex key there, and all I do is I just kind of push them gently from underneath like so, and eventually you'll see, there we go. Now if I move that around, there, that is 1 foot properly in place as it should be there. So we're going to do that for all 4 of them. Okay, so we now have 4 feet in place. Pop that down there. And then what we do is we grab our sidewall. So like I say, we've got the little sticky outy bits, the tabs here, and they are going to actually just pop in to the frame like so. So you can see that the back end has got this kind of rounded rectangle. That's going to be the back edge. You just pop that in and you can see that there's these little cutouts, and they will actually go around the feet, and the tabs go inside the feet. So we're just going to do that, and then we push down so the tabs slide into their relevant slots. Okay, we're probably going to need a bit of pressure just to hold that in, but that's the whole point of having the screws. So what we're now going to do, that will hold in place for a moment. We now want to grab one of our encapsulated nuts, so that's already been pushed into its little bracket, and then what we do is we grab that, we have the plastic side, so the flat plastic edge, that is going to be the lower half of it, and then the nylock part is going to be at the kind of the top half of it. So like that, it's going to be in that little gap, so you can see that's there. You can see the nylock part is sticking up at the top, and then we just hold our finger on that, grab one of our bolts, pop it through the hole, grab your 2mm hex driver and let it bite in. I'll leave that a little bit loose for the moment, and then let's do the other end. Grab another one of these, same principle. Put through there. And I'll tighten this one up now. Okay, so now as you can see, we've got the bolts on the bottom, our feet are in place, and everything is matched up and mated up nicely. So that's nice and solid. There's another one that we need to do here. And there we go, so that is one sidewall done. So now we're going to do exactly the same thing for the other. Okay, so that is our sidewalls done, and that is our main cage area in place there. Now you'll see there's 2 little tabs here. Now this is actually for this part. This is the firewall. So this is basically the firewall that will separate your battery from your flight controller bay and everything like that. So if you do have a crash, then it's going to stop it. Now you'll see when you slot that in, it's held in by literally nothing but friction. It mates onto the top surface, so once the top surface comes down, that clips in place. Now bear in mind that this can be, and it was on the original, fiddly to say the least. You may find that you run out of space in here for your flight controller. You may find it's a little bit, you know, a little bit too constricting, and you may want to push down into that. If you can keep it in there, it's by far and away the best thing to do, purely for the fact that it does give you that comfort of knowing that if you do have a nosedive for whatever reason, you're not going to end up with the bulk of a battery and all of the inertia that's coming with it smashing into your flight controller and causing damage there. It will give some resistance. However, like I say, it may be a case of you find there's a little bit too fiddly and you need to push the battery out a little bit further. Also for centre of gravity, if you can keep this in place, then you know once your battery's in here, it's going to at least be where it was designed to be. So I'm going to put it in there for the moment, and I'm going to try and build around it and see how far we get on. But that's basically basically where you want to get to before you actually start putting the flight controller and everything out like that in there. And we're now in a place where we can start doing some of that, and we can map out some of the electronics and where it wants to go. So now let's deal with the gimbal and the top plate. As you can see, the first thing that I've done is I've added all of the anti-vibration dampeners into their relevant holes on the top plate. You can opt not to do that to begin with. You may find that putting the PCB board on this way round is going to be a bit tricky to do. I've done it to begin with. It may be that it's not going to work out too well. However, we'll start with that anyway. Now, the next thing that you've got to consider is that the top plate and the gimbal kind of need to be put together before you do anything else. The reason is that basically this is the front bulkhead, and you have these holes here. Now those holes there actually mount up to these holes, well, not holes but screws on the back of the gimbal. You've also got two on the top. So basically the idea is that the two on the top will go into these. So these two here are going to go bump through there, and then these two on the back are going to go onto this back plate. So the first thing that we want to do is you need to get a 1.5mm hex screwdriver, and carefully, and I do mean carefully because Fayatech screws in my experience are made of pretty much chocolate, so they're very easy to strip. So we're going to take the two out the back first and foremost. So we've taken two out the back. Now you'll notice that this plate now, if you flop it out, will come away, and there's your control board and everything like that. Obviously we want that plate to be on. And then what we do is we take our bulkhead, and then what you want to do is you want to match up with the hole at the bottom. So if this is the bottom, holes at the bottom here, match up over the top of it, and that's where our screws are going to go. Now, while you could use the original screws, they will go in, you should find in your hardware, as I did, I actually had three longer 1.5mm hex bolts, and I believe the idea is that you are to replace the originals with these longer ones, because of obviously the extra thickness of the carbon fibre means that you're going to be losing a little bit of support if you don't have those longer bolts. Okay, so these are the two longer ones. I will show you what the two longer ones look like. So that was the original there, that was the original, and this is the one that actually gets supplied in the kit from Immersion. Kind of hard to see. Let's see if I can put them on my hands here. There we go. So you see the one on the right is ever so slightly longer, so worthwhile swapping them out. It seems to be that you get a spare, which is good. Okay, so I'll pop them to one side. So those are now in. Now you can see that there is a little bit of extra kind of hole to allow it to move up and down. The key is loosen them up a little bit, allow a little bit of slop. So there's now, as you can see, there's a bit of movement. Now go to the top ones, and we want to undo these. Again, be very careful. If you find that they're a bit stiff, just be really careful, because I have had hex bolts strip on Fayatech gimbals before, because they do seem to be very soft. Okay, so they are now out, so we've got two holes there. Now, let's think. I'm just going to try fitting should be fine. Yeah, what I'm going to do is I'm going to use the original rear bolts, so the ones that actually came out the back of the gimbal, the Fayatech ones. I'm going to use those because they're slightly longer than the existing ones. So that's the rear bolt, that's the existing one, and I'm going to try using the longer one in the top plate here. So what we do is we bring our top plate in, and that's going to line up to these holes. So let's get them lined up to the holes, and let's grab that longer bolt, and let's carefully, again, don't want to strip it, screw down one, trying not to go too far. And screw in the other. Okay, so those longer ones from the rear do actually work absolutely fine in that. Okay, so there's kind of a loose fit. Now what we want to do is we want to make sure that we can push the top plate up, so these holes are obviously all flush. So we push that up, and then once we push that up where it needs to be, we can then tighten them. In fact, what we'll do before we tighten those up, what we can do is we can actually put our encapsulated nuts into the relevant holes in the top plate. So one goes there, and grab ourselves a screw. And what this is going to do is it's going to pull the two plates together where they're going to be, with these actually loose. So you don't want these tight at this point in time, and then we can tighten them up afterwards. Okay. It's nice and tight there, and that's tight there. Okay, so now we can attack the back ones, and we can tighten them up. Again, don't go mad with tightness, it ain't going to go anywhere. You just want to have them tight, but not to the point where you strip the threads on the back of them. And then we can just tighten up those top two again. Okay. Okay, so as crazy as it sounds, now what we want to do is we want to take these side panels back off, and we want to take off the two top screws of this. Make sure that the screws on the back of this bulkhead are all tight, because we don't want the gimbal moving anywhere, because we now know that everything mates up as it should do against this top piece. However, to make your build a lot easier when it comes down to the electronics, what I'm now going to do is actually remove the bulkhead completely, and this will allow us to have access to the front of the NAZA for the ESCs, and this is of particular importance when it comes to doing the electronics, to make your life a lot easier. Okay, so those screws come out, drop them down there. Right, and now again, make sure these are nice and tight so it's not going to be moving around anywhere, because we know it's flush at the top here to the top bulkhead. But again, that's going to make life a lot easier from the point of view of electronics when you actually get to doing the final parts of the build, so heed my advice on that one. So now let's deal with mounting the PDB to the actual arms. Nothing particularly complicated about this. I'm doing this before doing any soldering. Now this is going to be a personal preference. It may be a case of you don't want to get anywhere near this nice frame with your soldering iron. The reason that I'm doing it, however, is that you've got to consider when you put this on to the frame, your ESCs are going to mount to the frame as well. So the distance and the angles and everything where the soldering goes is going to be somewhat reliant on where the ESCs are in part of that. My original XuGong, I actually wired it before putting it on the frame, and I found that was actually probably not a good idea, because I ended up with weird angles on all the solders, and it meant bent cables and things like that. So for this time round, what I'm going to do is I'm going to attach the frame first. So all we want to do first and foremost, let's fold the frame out, get the arms out of the way, and you can see we've got the mounting holes here. All we're going to be using is we're going to be using the supplied nuts here. These are 2.5mm hex, and we've also got the larger nuts on the bottom of those. Now I'm going to be using a 7mm spanner, a 7mm socket, which I've got here, just to be able to give me that extra bit of grip on it. Okay, so this is going to mount a specific direction. The front of the frame, if we look at this kind of the dead cat format, the front is that way, and what we want to do is we want to turn the PDB board upside down, so we've got the word XuGong at the top. That is the front, so the top part here, and then we mount it underneath the frame, and all we want to do is we want to put corner to corner, bolt through the corners, put your fingers down on top of them, flip it over, one nut on there, one nut on there. Okay, then we want to just grab our socket. I'm going to do it side on here. So hex into hex, socket over the nut, and just tighten it up until you can just about feel it gripping, and then loosen slightly. Same on this one. Just get past that nylon bite point, grip, undo slightly, gives you a little bit of movement, so we can now make sure that our holes line up for this part. Bolts into the holes, flip it upside down, and same again. Okay, so let's make sure that the angles are all okay. I'm just loosening them all off slightly so I can move it around, give it a bit of wiggle room. Okay, so you can see there's a little bit of wiggle room there, so I'm going to seat that exactly where I want it to be. I'm going to hold it this way round, and then we'll tighten them up. Okay, so we now have the PDB mounted to the frame. So now we come on to the bit where we've got to start thinking about the soldering. We've also got to think about motor placement, we've got to think about the ESC placement and how all of that goes together. Now, like I said before, I'm going to be using DJI E300 series, so I've got the E300 motor, I've got this is the bullets that come with the XuGong, the bullet extensions, and obviously I've got the frame all laid out, everything like that. Now the first thing that you've got to consider is the fact the E300s come with a large amount of this single wire cable basically. Now the placement of the ESCs is going to be about here. So this is basically where it's going to be. Now you can see that actually the terminals, positive and negative here, are only there. So we've got a lot of cable that doesn't really need to be used. Now again, this is going to come down to personal preference. I, for one, am a little bit wary of cutting a cable to this kind of length, purely for the fact that if you get it wrong, or if the soldering goes wrong, and also the distance away from the solder, you don't have a lot of heat dissipation, anything like that. So what I'm going to probably do is I'm going to actually loop the cable round, and I'm going to actually pin it down using either heat shrink or tape around the arm like this. Then I'm going to do the soldering from here. The reason being, if something went horribly wrong, as you can see, I've got a nice amount of cable that I can then use to correct the error. The other thing that I do like to be able to do, as I've mentioned before, is I like to be able to reuse all of these things. So if for whatever reason I didn't really like the XuGong, or I wanted to use my E300s for a new project, then I'd be able to unsolder it and I'd still have a good amount of cable that will hopefully become quite useful in the future on different builds. So that's my personal preference. Many people are going to go the short route. Obviously if you do that, just plan it and really think about it. Okay, so that's the actual ESC placement. Now the other thing to consider is the motor. Obviously the motor is going to go under here. Apologies for the lighting, it's a little bit shadowy on this particular one. So the motor is going to go under there. Obviously we're going to mount that with some bolts and screws. However, when we put the cables through these little holes and through here, okay, you can see that with the motor there and the ESC there, it ain't going to get there. Now you've got to bear in mind that when you actually swing the arms around as well, there needs to be some movement and flexibility, and that's why Immersion have actually included these in the design. So what we're going to do is we're going to put one of these in all of the holes. 1, 2 and 3. Okay. And while that does look like there's quite a bit of excess, you've got to bear in mind, like I say, that there is going to be some movement. So when you swing the arm around, you're going to need this cable to actually be long enough so it will bend around and kind of follow the route. So let me just demonstrate that for you. If I just unclip it from below, I swing it around here, and then I put my motor back where it was, then you see these wires now are going to need to have that flexibility on it, so when it swings all the way round to the final position that it doesn't get all snagged up. So that's the reason they've made them this particular length. So that's basically how I'm going to do it. Now the other thing to think about, I'll just remove these from this hole. The other thing to think about is this nut. This nut can be a bit of a killer on ESCs if you're not careful. If you actually just use the flat face of the ESC, if I just hold it up here, you can see that potentially that nut, I'll just try and zoom in a little bit, potentially that nut can get quite close to some of the wires. Now when you're using these ESC extensions, you can see that actually there's kind of a lump, and they've done it, whether this is deliberate or whether it was by accident, but either way I've placed them so there's kind of a high side and a low side, so this will actually clear that nut when you're moving it around. If you still feel that it's a little bit in the way, or if you're a little bit worried, the one thing that you can do, get a bit of foam board, get a bit of cardboard, something like that, and you just stick that to the underside here of your ESC. It just will move it away. It will just kind of raise the height a little bit. Kind of hard to see in this, so it will just raise it up, and it will mean there's less chance of there being any rubbing on that nut. So let me just zoom back out there. Okay. So yeah, so they're the considerations when you're actually mapping out what you want to do with this. My advice is certainly we're going to mount up the motors first up, just to make sure that you've got the full swing and the full range, and you're not going to get any snagging, anything like that. Then I would say get a bit of tape, strap it around your ESC so you're comfortable with the position of it, you're comfortable that you're not getting this nut in the way and it's not rubbing against anything. And once you're all happy with all of that, that's the point where you can then say, right, let's get the soldering iron out, let's get the cable cut to the length, and we're going to do that. So that will be the next stage. Okay, so now we're going to move on to just getting the ESCs ready to be mounted onto the arms. Now what I'm going to do is give them a bit of a spacer, because I want to just avoid knocking into that nut potentially and just rubbing on it. This is an optional extra that you don't have to do. You can mount them straight onto it. Some people will use heat shrink. To be honest, if I had the right amount of heat shrink, I'd probably use it. But for me, this is something that I used on the last one and it worked very well. Basically what we're going to end up with is something that looks like this. So we've got the ESC, we've got the coiled wire. Again, this is completely optional. If you want to chop the wire to length, as you've seen before, you can do that. I'm going to coil it, and I've literally then used just a bit of foam board here. It's 50mm by 24mm, and it just lays on the bottom of that, and then I've just taped around it. The idea is there's a bit of gap between the tape and that. There should be a bit of ventilation for it, shouldn't cause a problem, and obviously that will then be able to mount to the arm. To demonstrate what the arm looks like when it's all mounted, here's one I made earlier, as they say. So that's actually the motor mounted on there, the extension cable's on there. You can see that the wires are hanging down at the moment because I've put it through this first hole. I may choose to move it, I might do a bit of braiding on these, but ultimately the ESC, as you can see, again, all I've done is I've used some black insulation tape and I've just strapped all of that bundle together and it's just held on there. The important thing is that the gap here needs to be maintained. So yes, I could use a cable tie, but if I have a thick cable tie, problem is when I come to swing the arm around, it's going to snag on that cable tie, and by using something like really thin heat shrink or tape, you can actually get it to close that a little bit further, and you can see there's an ever so slight gap there that just gives you that barrier, and it means that you can fold it all the way into the middle. Otherwise you can only fold it about here. Not that that's going to be a major problem, but like I say, this is something that I've done before and it works quite well. As you can see, when you do curve it all the way in, the wires, they're not taut, it's about the right length, I would say. I have braided the wires at the top here by the motor, but again, that's optional, and it may be a case of once I finish with it, what I'll do is I'll just strap these down a little bit better so there's a bit of flexibility, but that's what we're aiming for. So I'm going to continue just making the last one of those now so you can see how it's done. Nothing too complicated. All I'm going to do is get myself some insulation tape, decent amount of that, chop that, get my ESC and lay it down on top of it, and then what I do is I just make sure there's a little bit of a gap between the bullets and the end of the board, and then I just lay the tape down over the top of the E300 sticker, nice and flat like that. Give it a once around and up, and then what I'm going to do is I'm going to get my wire, I'm going to wrap it around like this, pinch it in place, and then curl that tape back over and just pin it down. And again, as I'm doing this, the reason that I'm keeping this wire is because I know for a fact that I will probably end up using these motors and these ESCs for other projects, other videos, things like that. I do like to be able to move them, chop them around. I'd love to be able to keep them on there, but unfortunately I just can't afford to continue buying new sets for every model that I own, and frankly I can't store them once they're all built anyway all the time. Okay, so we've got another little bundle there, and that is going to end up on the underside of this about here. And what I'm doing is I'm going to actually attach them to the arms first, the reason being that what I want to do is I want to be able to make sure that this wire, when I actually cut it, is going to be kind of the right distance. So I'm literally going to snip it about there. I'm going to make it so I can just make it the right angle, and by doing that I know that there's a nice joint on there, it's going to be at the right angle, there's no stress or anything like that going onto it. It's going to be a bit fiddly, but it's always going to be a bit fiddly. So yeah, so that's what I'm going to do. So now what I'll do is I'll attach all 4 ESCs to the arms and we'll go from there. Okay, so now let's move on to the soldering part. Now before we do that, the one thing that we want to take a quick look at is the way that these DJI E300 wires actually work. Obviously some ESCs, if you're not using the DJI ones, they'll normally come with two wires. They'll just have a ground and a positive. However, as you can see here, if we will get in focus, this is kind of the format of the wires that you get with the E300s. So this is kind of the end wire that's on it, but if we strip it back, so this is just a piece that I've already chopped. If we strip it back, you can see that actually what they are is it's coaxial wire. So the negative or the ground is this coil around the positive. So what you've got to do is basically peel it back, and you need to then sort of bunch up the coax part of it, making sure that no little tiny strands are getting in the way, like so, and that's going to be your ground. And then obviously then you're going to strip the negative, the positive bit here. So as we can see on this one, if I just zoom this in, there, so that's a pre-prepared one that I've done already. This will be the first one. So I've got the positive is now been stripped, I've got the coaxial negative is there. What I'm going to do is I'm going to pre-solder the pads here. So I'm going to put a glob of solder there after I've put some rosin flux on it, and then it's literally just a case of we're just going to lay these down into the solder. Job's a good one. Next thing we want to do after that, once we've done all 4 of the ESCs, is we want to get the PMUv2 powered up, and that's actually going to attach here where it says FCBEC. That is actually a 12 volt pad right there, so we're going to be able to use that for the PMUv2. So first and foremost, what I'm going to be using is this is the resin flux pen, and I'm going to put a little glob of that on the pads. I'm using about 435 degrees on a temperature controlled soldering iron, which is quite hot. If you don't have a temperature controlled soldering iron, I strongly suggest that you maybe think about going out and getting one. Okay, a little glob of solder on there just to get heat to the pad. Preheat the pad. And then a nice dollop of solder. Okay, not my greatest work, but my soldering sucks anyway. Okay, so that's the soldering done. Not my finest work, and as I say, I'm absolutely rubbish at soldering, but it should be absolutely fine. One thing that you do need to be very careful with, because this braided wire is basically lots of sections of very small wire, you can see there's a bit of sort of swarf lying around here. What you need to be careful with is that none of these tiny little strands on the negative actually can arc onto the positive. So what I'm going to do is fire up a hot glue gun, and I'm just going to dab some hot glue around the edges of the positive, just to make sure that if anything did try and sort of fall off or get loose on here and try and penetrate onto that, it can't spark out. And obviously the last thing we want to do is short out the electrics. So so that's the final stage of the actual soldering that's going to be done, and once that's there, then it's just a case of getting the PMUv2 soldered on. Okay, so that is my PMUv2 soldered on. Now, as you can see, what I've done is I've used 3.5mm bullets, and that is because my PMUv2, which is here, I also put some 3.5mm bullets on there a while ago. Just means that I can swap it out, I can move it about again if I wanted to use it on, say, a Phantom or something like that. It gives me the option of doing it. A little bit more cable than I'd like, but still, at least that's now going to be like that. So that is the soldering all done now. So after that, it's then just going to be a case of getting the wires put in. You do need to put the wires in first before you actually do it, so we'll move on to that next. So now let's talk about the plugs and getting everything sort of plugged into their various locations. In the box you've got a number of different leads in a little cable bag. What I'll do is I'll go through them one by one and show you where they go and what they're going to be doing. You will first and foremost have one of these. So this is a standard servo connector with a little kind of Molex on the bottom. You should have 2 of those in the box. Now what they're going to do is they're going to go in these ports here. One of them is going to be for the receiver to PPM, which is going to be that one there, and the other one is going to be FC PPM, which is the top one there. Now you're probably asking yourself the question, well, what the hell is he talking about? Okay, well, receiver PPM, this is the one that actually goes off to the EzUHF. So if you're using EzUHF, you'll be using it in PPM mode. That means you will only have this one cable. This is going to send all the information from your receiver to your flight controller all down this one cable. It means you don't have to have, say, on this, which is the EzUHF 8-channel diversity means you don't have to use all of these. You can just literally plug the 1 ppm into it, and that will actually allow you to just use it with that one cable, which is all good. The other one, the one that actually says FC ppm, this is the one that's going to go into your NAZA. So that's going to take the signals from your RX through the board and to the NAZA. So that's going to go into the X2 port of the NAZA. Next up, we also have this little black cable here. Now this is for EzUHF and the downlink. So all we need to do for this one is we just plug it into this slot here. Carefully feed that in. There we go, a bit of a wiggle. And then this end of the cable, then that is going to go, if we take a look at EzUHF again, that is for the downlink, so that's that little port there. So it's going to go kind of this way round, and it will just pop in there. I'm not going to do that for the moment because I don't have an easy antenna tracker or anything like that as yet. Then I'm going to probably leave that one out for the actual initial flight, but that's basically where that one's going to go. Okay, also then what we've got at the top here, this is our little USB connector. This is going to be for powering up, and also actually going to be for taking the video out of the GoPro, which is attached to the gimbal. That one is just going to go on the front port here. If you just flip this upside down, you will see written here, there we go, once that comes in, you've got GoPro flight camera, and then you've also got the gimbal plug there. So this is going to go to the GoPro one, which is the middle one. So let's flip that back upside down. So this is going to be for the gimbal. This is a plug that you don't have to do now, to be honest. I mean, you can plug this in later on because it is actually going to be quite accessible. In fact, I may just leave it off, but I'll plug it in for the moment here, just so you can see. So that goes in there. Okay. Next up, you've got your transmitter power. This is for your video transmitter. Goes in like so. This cable here that goes into this port, this is going to be the GPS. Now that is, if I demonstrate, here is our NAZA. So at the moment I'm actually, I'll take that out, that's actually a phantom LED module, which I might decide to use, but that's where the LED goes in, the NAZA LED. And then we've got this port here, so this is going into the Expo port. And basically this is kind of a lead through, so the PMUv2 connection is going to go in here, and then as you can see you've got this little cable coming off here, and that's basically taking information that's coming from the GPS. GPS goes into the PMUv2, and then it sends the information to the NAZA. It comes through these cables, and basically this is taking that information and it's putting it into the board, so the board can actually take the GPS information and use it for its OSD. So that's going to go into this port here. Obviously you don't really want to plug that in until you've got this mounted and you can put everything together. So a little bit of a fiddle it's going to be to get it all connected once you have to flip it upside down and put all of the little rubber dampeners in, but that's the general layout for it anyway. When it comes to actually getting the NAZA fitted in place, there are a few challenges that you're going to have to overcome. There isn't a huge amount of room to play with. There is more than there was on the old one, but you still have to sort of find the best way of doing it. Obviously the NAZA initially is going to be fitted here in this little box here. You've got to bear in mind that you're going to need room for cables at the back, and you're also going to need room for cables at the front. The ESC cables, so you're going to have at least 4 in the front, and you're going to have definitely the Expo, the LED, the X2 and potentially the X3 as well are going to be used at the back here. So you can't bunch it too far up against the firewall there, and of course you can't move it too forwards here because you're going to be banging up against this front bit. Ideally, roughly around sort of halfway point is going to be the best thing. You are going to be able to, you know, get your fingers in through these holes at the bottom, but it's going to be pretty tight, so just bear that in mind when you're planning it out. From the point of view of the PMUv2, that's going to plug into this little extension cable, which is the piggyback for the GPS as well. So that is going to go into the Expo port. So on your NAZA, upside down here, Expo port, as you can see with the label just there. Expo port is this one, so that's going to just push into this recess here. And then your PMUv2 is going to plug into this. Now, as you can see, if I just lay that down like that, that's obviously not going to work. So we're going to end up bending that forward. Now, the other thing that you're going to find is a challenge, and I've actually asked the question of ImmersionRC whether or not they will bundle an extra one of these cables without the piggyback, because it would be quite handy, is the NAZA V2 LED, this chap here. It comes with quite a thick cable. It comes with, you know, the same cable as the PMUv2 does. Now, if we compare the two cables, what I've done on this one, so this is the NAZA V2 LED and this is the PMU one, what I've actually done is I've trimmed down all of this plastic, because the biggest problem, if I just demonstrate by plugging in the PMUv2 to it, is that with it like this, you can see the overhang at the back is massive. If I was to try and actually squeeze that in there without going too far into the firewall, it's getting kind of close. It can just about do it, but it's still getting kind of close. So to combat that, like I say, what I've done is I've actually just removed with a scalpel, a little craft knife, very carefully so as not to cut into the cables. I've just removed all of the plastic so it's got a bit more flexibility. And then what I'm going to do is I'm actually going to bend it forwards over the top of itself, like so. And then I've got some heat shrink, and I'm just going to slide that heat shrink over the top of it like that, and then basically that's going to give me the ability of just having that little bit more space on the back of it. So all I've got to do now is just shrink that heat shrink up, being careful not to melt the cables. And as always, this is all optional. It will fit if you do it, but it's just going to leave you with that little bit less space in there. So okay, so that's all now heat shrunk down. So now what I should be able to do with that V2 LED cable is slot it in there, and as you can see, that's now in there, and we've got a little bit more space to play with before getting into any trouble. So we should have plenty of space now at the front for our ESCs, and we've got a bit of space at the back right there. So then it's just going to be a case of fixing down your NAZA. Obviously what you want to do is make sure that you use as much surface area as possible with your sticky pad straight onto the carbon there. Stick that down, make sure that's nice and clean before you do it. Stick that down, you want to make it nice and straight, and then you can then have space to put your ESCs in after that. So now comes to the sticking down of the NAZA. Now I suggest that you make sure that you've got your plugs actually in the NAZA at the time. Again, that's just to make sure that you've got your firewall in place and that you're not going to put it in a place that's going to cause problems. I'm personally, rather than using the one that comes with the NAZA, because I've used this so many times, I've run out of those sticky pads, I'm actually using No More Nails tape, which I've found to be massively reliable. I've never had it fall off as yet. Obviously you need to make sure that this is held down very securely. This gives a nice bit of kind of anti-vibration because it's a sort of a soft pad as well. What you've got to bear in mind is, because of the kind of cutouts here, is that you don't have full surface area there. So just be aware of that, and obviously we also don't want anything dirty, greasy, anything like that that could make this unstick. If this thing comes unstuck when you're in flight and starts rattling around, you are going to crash without a shadow of a doubt, because all the IMUs and everything that are in here to know where the aircraft is are based in it. So just bear that in mind. You've also got the option, once you've actually put this on, if you want an added security, because of this cross section and these holes here, you could strap a cable tie right around it, and that's just going to give it that extra little bit of security to know that it's not going to wiggle out of place. So with that in mind, I'm now going to unpeel this and get it stuck down. Okay, so that's now in place. You don't need to be completely centered on it. The NAZA itself can cope with being off center slightly, so you can go to the left, you can go to the right. If you wanted to put something in this little space here or this little space here, you could do that. Obviously just consider the surface area that you've got available to you underneath in regards to the actual stickiness of it. And like I say, if you want to, you could now actually put a cable tie around this to kind of strap it down a little bit further, or even a Velcro wrap, just to give you that little bit of peace of mind. But with that stuck down, make sure it's not moving anywhere, make sure it's taken, give it a good squeeze from the bottom. And if we turn it upside down, you see there's quite a large amount of surface area. I've not stuck it central on this, I've actually moved it over to one side because I want to have the ability of slotting something in, maybe in, well, possibly a BTU unit or something like that. It gives you that option anyway. So that's all stuck down, and as you can see, the firewall's now in place, it's not knocking into anything. Now it's just going to be a case of getting the frame together, getting the wires in for the ESC, and then we can start completing the build. With the NAZA V2, you've got to consider the PMUv2 placement. You're going to have the GPS is going to be plugging into it, so you're going to need that available to you. You've also got the power leads coming off here. You've got this that's going to go to the X3 on your NAZA, and you've also got your Expo port here, which is going to go to this little extension cable there, as we've already seen. I've got power is coming from the bullets, which is going to the PDB board, as I've already shown you. But you've also got a CAN bus port on the bottom. Now, if you're a person who likes to do kind of tuning via the BTU, or if you were going to use a data link or anything like that, you're going to need that available to you. Now, options for fitting it, we're going to have the video transmitter is going to go on this side. You've also got the ability of slotting it in on this side, on this little cradle here, but you've got to bear in mind, if you do decide to kind of slot it between this bulkhead, which is going to come slotting down on here, or anywhere in this kind of gap, while it will fit very snugly, and it is a lovely place to put it, you've got to bear in mind that you're going to need access to that, that port there. Now if I just bring the top half of the frame in, we can kind of dry fit to see what's going to be available to us. So if I just move this out of the way there. Okay. So that's basically now laid on top there. So what have we got available to us on the underside? If I just clip them in. So on the side here, we've got this space here. Now there is a hole here, but unfortunately that's not quite wide enough to actually fit the CAN bus port through. If you look at it on the side here, other options, you could put it sideways on, except it's not quite tall enough, and that's not going to work there. So from my point of view, what I'm intending to do is I'm actually going to strap the PMUv2 to the back here. I'm going to strap it just on the side here. I'm probably going to use some Velcro, heavy duty Velcro on this part here, and also then I'll be able to cable tie around it. By putting it here, what that's going to give me the ability of doing is I've got plenty of space for my power wires to go up to my bullets on the PDB, which is going to be up here. This is going to give me the ability of going through these holes or wrapping around to get to my NAZA. But most importantly, if I wanted to use a BTU or something like that, the underside is going to give me access to that port, and if I put it up high, nice, like sort of in the centre there, then there should be enough when that's plugged in to give clearance when we actually touch down on the ground. So it's just worthwhile thinking about these things. When I built the first XuGong, these were the kind of things that tripped me up, and I ended up me having to sort of take it apart, put it back together again. It's basically just managing your cables and making sure that all the ports that you are going to use are going to be available to you. If you're not going to use any of the CAN bus stuff, then you're not going to need to worry too much about it. There's so much functionality in this board already that comes with the XuGong that you're not going to want to, for example, you're not going to need to use IOSD, but the BTU unit through CAN bus is quite a good thing to have, and likewise if you're using ground links and stuff like that, then it's potentially something that you're going to want to include. Okay, so this is the final position that I've actually decided to put my PMUv2. It is quite far back, but by keeping it back, it keeps it away from the electronics, the VTX, everything like that. It's no bad thing. There's plenty of cable on this. The actual connectors are going to be over here for it, but there's plenty of play on there, so I'll be able to manage that. The main reason, as I mentioned before, is because now I can get to the CAN bus port on the bottom there, and also if you look at the location I've chosen, you've got these little holes in the frame. Kind of hard to see with all the shadow. There's a hole there, there's one there, there's one there, and there's one there, and that means that I can also either put a cable tie or some fishing wire or something, basically just to pull it back against the frame before I do it all up without getting in the way of the battery too much. Next thing I want to do then is these cables, the Expo cable, have got to get into this area here. The firewall is going to be sitting about here, so I need to make sure it goes through this hole here. But what I want to do is do a bit of neatening before I do that, because of the two cables. What I'm going to do first and foremost is I'm going to get some of the braided cabling here, some of this stuff, and I'm just going to cut a length of that that's going to go into the bay inside there. Before I do that, I'm just going to get myself a little bit of electrical tape and just get that ready to use, and then I would normally use black, but unfortunately I've run out of it, so I'm going to use green heat shrink. I'm going to bung that over the top of there, I'm going to bung that over the top of here, and this is all going to be just to make things a little bit neater with that braid, because it does get rather frayed at the ends. So that's going to go all the way down there, and we'll eventually tuck over the ends of those cables. Okay, then I'm going to get myself some of this braid and work out how much we're going to need. So it's probably going to be about that much there. And we'll chop that. Okay. Now we're going to get that bit of tape, and I'm going to actually tape these two cables together purely for the purposes of feeding it through the braid, because if you do two, it can get a little bit frayed and be a bit more awkward. So I'll loosely put them around there, like so, and then we've just got to open up the braiding around them and snake it on down. There we go. Okay. And then what we want to do is we want to feed all of the ends of that braiding into our heat shrink as best we can, leaving no edges. Then slide the rest of it down there. Get the heat shrink over the top. If we can, probably need a slightly wider bit of heat shrink, but I'm sure this will do fine. There we go. Okay, and that is all ready now to be shrunk. Okay, so that is there. If we wanted to, we could put some more heat shrink on the end here. Not particularly fussed about that, to be honest. Might do in a moment. Anyway, that's made it possible now, so we can now feed these wires through into the NAZA bay, like so. And yeah, with a bit of heat shrink there, I think probably be a good idea. That then gives us the ability, folding them back and getting them all plugged in, which we'll do in a moment. So there we go, that's the final bit of braiding done, and as you can see I've tucked the PMUv2 Expo cable just down by the side, and what I'll do for neatness is I'll run a cable tie or a piece of tape around the NAZA just to hold it to this bottom bulkhead as well, all the way wrapped around it once I'm done. But there's a bit more cabling that we want to do. Some of the ESC wires might be a bit long, so we might want to feed them around there and do the same thing, but that gets that put in place anyway. So you've now got your V2 on the side there, all nice and neat, running into that. So now we're almost ready to make the top to the bottom. So now we're getting a lot closer to being able to make the top to the bottom, and also get the top of the cage actually down on top of it. What you've got to think about though, we've now got the Expo cable, we've got the X3 put in place. What you've also got to consider, if we just go back to the PDB, is that because we're going to be using the PPM, we need to make sure that the flight controller to PPM cable, this cable here I believe, yeah, flight controller to PPM, this one here, that's got to be plugged into the X2 port. Now that X2 port is housed, if I just zoom in here, all the way under here next to the X3 port. So bear in mind, before you do all of this, this is the moment that you want to get that plugged in. So what I'm going to do is I'm going to remove it from the actual PDB, put that to one side. Because the two halves aren't mated together, I can simply slide out the firewall now and just take that out of the way, and that's going to give me access to the back of the NAZA, and I can slot this in to the X2 port, which is the one right next to the X3. And you can see what's nice about this frame with all the holes in it is you can actually see them. You can get to them a little bit. I can get my fingers in there. A little bit fiddly to get on camera, of course, but the principle is all there. And let's see if we can see that down. Okay. Right, and that's now in place. So you can see on the bottom there, X3, X2, side by side. Now you shouldn't need to get to any of the other ports on the back here. That should be everything done with the LED. So that's now in a position where we can at least get that out of the way. We can put our firewall back in place. So just slide that down into the slots. Okay. And that is the rear end of the NAZA, all prepped and ready, certainly from what we want to do with it anyway. There is of course one thing that we do need to consider, which is the V2 LED. What I've done is I've unplugged that now, and basically I'm just going to feed that up through the bottom here, take the firewall out again, and then I'm just going to put that back in place. Like so. So that now means that the LED runs down the bottom here, and what I'm going to end up doing is using my little custom made mount that I've got, is I'm going to actually attach that onto the bottom like so, and then that's going to be shining down at a 45-degree angle. So before we go putting the top onto the bottom, what we need to do is consider the GPS mounting point. Now there are 4 custom holes here, 1, 2, 3, 4, and they are specifically designed for the DJI mount that actually comes with the V2 NAZA. So they just fit on there. Now there's 2 ways that you can do this, the right way and the wrong way. The wrong way is to put your bolts down through these holes and then to attach your nuts on the underside. Of course, if you do that, what you end up is you have some potentially sharp areas that your battery's going to stab into. If your battery gets stabbed and stuff starts leaking, bad things happen, fires occur, and you lose everything. So the better way of doing it is to get your bolts and to poke them up through the holes and then tighten your nuts down, so all 4 nuts are going to be on the top here. The alternative, for those who don't really like this, I mean personally I've never been a fan of the original NAZA V2 GPS, because it came literally at the other end with this little stalk here. There was no way of gripping it, there was nothing you could do. It basically meant you had to epoxy that in and then you stick your GPS onto the top of it. The alternative is to make things even more compact, and that is to get yourself one of these, which is a little flap down version. Now the great thing about these, number 1, they're very cheap, but number 2 is they actually come with what I believe is a 2mm thread, and the great part of that is that they will actually screw down into these holes. So you can actually turn this into an integral part of the of basically putting the 2 together. So what you do is you just put one of your little nut encapsulating devices in here, and then you screw that down, boom boom boom, and it will actually hold in place there. Obviously a little bit of Loctite might be an idea. It shouldn't be needed because there's an eye lock nut that it's going into, but by doing that you then don't have to use these 4 holes. You've got a nice flat area here that you can use for your receiver, and also it's going to grip it nice and tight on there. And then all you need to do, of course, is put a little plate, a little 3M sticker there, and you put your GPS module on it, and I'll do that later on. Another little trick for people who are constantly frustrated about the fact you've got epoxy, what I did with this mount is I literally drilled a hole in the side of it, and I just used a small tap, and I just tapped the hole out so it had a thread in it, and then stuck a bolt, rather long bolt, on the side of it, and that means it will actually grip onto the carbon rod, and if I want to remove it I just undo that and it will pop off. Nice and simple. I did end up gluing this one down the bottom here, however, so that's all glued in and epoxied. So an option for people who want to do that. Anyway, like I say, I'm going to be using this, so I don't need to worry about putting this on, but if you are going to be using the DJI mount, then you need to think about this before you put everything back together, because otherwise it might be a bit difficult to get to the underside of this once it's all in place. So with all your wires in place on the board, the next thing you want to do is get your rubber dampeners in place. So pop them all through. It's a little bit of a struggle. I haven't shown you how to do it because it's something that you really need to sort of clutch quite tight onto it. You need to be able to mould it around. Basically, you'll find your own way of doing it. It can be done, don't worry about it. And basically what you want to do is just pop them through. Now I appreciate that in an earlier part of this video I actually attached them to the top frame, so you're probably cursing at me by it now. Hopefully you saw the annotation that said don't do that. But the reason that I've done this will become apparent in a moment. Anyway, just put these now onto the PDB board, and then taking a look at the ESCs, what I've done here, because there's a lot of ESC wire, I've actually shortened mine down. We're probably talking about maybe about 4 inches, something like that. All I've done is I've curled them up and I've put some heat shrink around them, and I've also marked each one with its corresponding motor position. That makes it a little bit easier for us to be able to tell where it needs to go. Now the next stage gets very fiddly, where we actually mount the 2 boards together. What we need to do is, before we mount the 2 boards, we actually have to get the electronics into the NAZA, and then we can start putting the screws together. This is the way that I've done it. Obviously there are other ways of doing it. I've done it slightly differently from the manual, but hopefully this will work for everyone as they're watching it. Okay, so now we've got our PMUv2 in place and all neatened up. We've got our Expo lead plugged in and it's just tucked down to the side of it. We've got our LED placed and making sure that it's got the actual wire coming out the bottom, so you can read your LED nicely there. And the other key thing that we've got is that the bulkhead is not attached to the front here. Now back before we get into this stage, I suggested you mounted your gimbal and then basically take your top plate apart again, because it would make life easier. Now there was a specific reason for it, because what we're going to do now is we're going to actually mount the top plate without any of the rubber dampeners or anything like that on there. So apologies if you've already done that following my other advice. I've had to retract some of that. We're going to mount this on there, but if you do that and that front bulkhead's there, you're not going to be able to get to the electronics. The reason being, you can't get your fingers through here, and you can't really bend around to get servo wires in there. The main reason for that is this horrible bulky LED, and I have actually reported to ImmersionRC that that is going to get in the way to be able to move your NAZA all the way back, and hopefully they will do something about that. They may not. Obviously that's just my advice on this build. I think it would be a lot easier if that V2 LED with that big bulky cable wasn't there. You don't have to use it. If you don't use it, you're not going to have the LED. Obviously the idea of this board is that you're going to be using the OSD, so you'll be able to get your battery levels and everything through that, and the only other functionality you're going to miss out on is if you need to update your firmware on your NAZA. The V2 hasn't had an update on a firmware for about 1.5 years now, so I very much doubt that's going to be needed. So you could just scrap it and not bother if you wanted to, but just be advised, if you have, or if you are intending to use that, then just please make sure that you don't put that bulkhead in, and then we'll find a way around that in a moment. So anyway, so now we're going to mate the top and the bottom up. You've got to make sure that your bulkhead is in the right place, otherwise it won't click together. And once that's done, we can then snap all of this down. Okay, so now what we're going to do is we're going to put a encapsulating nut in the back. Now I'm going to leave this one off, this hole here, and that's purely for the fact that as you've already seen, my the LED, not the LED, the GPS. Now I'm going to leave this one open here, and for the reason that I'm going to be using my GPS stand as a screw. So I'm actually going to use an encapsulating nut there, and then I'm actually going to screw down my GPS stand, which is here, using the screw thread on the bottom of it, and that's actually going to be one of my structural low points. So that's just going to screw in like this, and then as you can see, that's now actually part of the frame, so my GPS is going to go on that, but it also means that I've also got a fold down GPS, and it's not going to get in the way of the battery, and it's not going to foul up any of that. So completely optional if people want to do that. Obviously the one disadvantage is if you do it too tight, then when you undo it you might start undoing that screw, but you've got plenty of other screw options there. Now I haven't done anything on these two holes yet, and the reason is that we want to have some flexibility for that front bulkhead. The big problem with actually mounting everything to the top, so once you get your PCB board in, when you mount it all to the top, the PCB board, as you can see here, is actually going to completely stop you from doing up those holes, so you need to do them beforehand. However, we need to get the electronics in first, so it's a little bit fiddly from that point of view. I'm going to undo this because I don't want this in my way. And obviously I will return to doing that up at a later date. Okay, so now you've got the screws in here. Again, you'll probably have 4 if you're using that. Obviously, if you've done the GPS, if you're using the NAZA GPS, then you would have also done that beforehand as well. So you've got the bolts coming up through the bottom, as discussed. But you'll also see that you've got some other holes that still haven't been filled in, and we've got a bit of flexibility here. Now, the reason that I've done it this way is to basically give you access to the front of the NAZA whilst we're doing the electronics. Otherwise, it can get a bit fiddly. If you've used the V2 LED, the biggest problem is that you physically cannot use that firewall that's down in here unless you push the NAZA all the way forward, because the cable is just too big. I've actually asked ImmersionRC and whether they decide to do it or not. I've suggested that they bundle 2 of these kind of extension wires, but obviously only one with the GPS tag on in there, and that would then let you move everything back so you could get to the front of it. However, if you use the method that I'm using, then you should be able to sort of thumb your way around without having too much hassle, and it actually makes life a little bit easier when it comes to the electronics. So with that in mind, let's bring in the electronics. So we've got no motors on there as yet, and that just means that we can fold it all up and keep it like that. I've got all of the rubber dampeners in there on the actual board here, and then we've got all the cables plugged in at the bottom. We've got all the ESC wires. I've made them a little bit neater with this heat shrink, so I've basically wrapped them up. I didn't want to cut them. Obviously you could choose to cut them if you wanted to and re-crimp them, bit of hassle. So I've just wrapped them up and I've put heat shrink around them, and then I've used M3, M4, M2, M1, and I've labelled the various ESCs with the correct motor orientation. So we're now in a position that everything electronic wise is all ready to go. All we've got to do is then make the 2 up. Now what we're going to do is we're going to actually flip this over, and we need to basically route the ESC cables through the various holes on the actual top board. So we know that this GPS cable has got to come up to the bottom of the board. That's fine, we can deal with that in a moment. So let's use M1 for example. M1 is going to go in this hole here. This is obviously your personal choice. You could put them through the front ones if you wanted to, but I'm going to go with M1 through this slot here. I'm going to go with M2 through its corresponding slot on the other side. And then I'm going to just simply have M3 and 4, a little bit hard to see here, but I'm just going to put them through the main square hole and push them out to the front. Other things to consider: your video transmitter. I'm going to put the video transmitter wires, so that is, for you it'll probably be the big black 5-pin connector, will go through here, and the video power, which is this one here, goes through here. Okay, so that's the main wires going through where we want them to be. The other thing that you've got to consider is that this one here, that's coming from the X2 port of the NAZA, that's got to come up and that's got to actually mount onto the port on the underside here. So we can actually connect that up now. Unfortunately you guys aren't going to be able to see me do that because it's all a little bit tight. Okay, so that is in that port there. This, which is going to our EzUHF, this is for the receiver, that's just going to slot into this little rectangular slot there. And then we can now kind of just sit this down on top of the top plate for a moment whilst we take a look at the front. So, okay, so now we can see we've got ESC wires coming through the front here. So these are the rear ones, and then we've got the two front ones coming through here. Video wires we can get out of the way there. And this is the main reason for me doing the bulkhead in the way that I've done it, is that this now gives you the ability to get to the front of the NAZA. So all we need to do now is we just need to plug in the various ESC wires. So I would suggest you do 4, 3, 2, 1 in that order. They are labelled, so 1, 2, 3, 4. Okay, so M4. And this is why I use the heat shrink and actually mark it so I know which one's which. This one is M3. This one is M2. I can just slide that down the side in here. Make things a bit neater. And that's going to go to M2. And then finally M1 in M1. Boom, okay. So that's all of our ESC wires in place as they need to be. Okay. So all wires are where they should be. Hopefully nothing's pinching. Just need to have a little look around. Obviously you don't want things like this happening where stuff is getting in the way. So you just want to make sure that all the wires are pulled through their corresponding holes in the way that you want them. You can of course get through this side and just use something like a little tool just to pull them tight. So for example, what have we got here? This wire here is getting in our way a little bit. So I'm going to push that through there. There we go. Okay. So electronics are pretty much in a place where they want to be. Okay, so what about the bulkhead? Well, now we can actually fit the bulkhead, but the first thing that we want to do, we've got to get the gimbal bulkhead here, and then we've got to get the two side bulkheads. Now you need to remember to do this first, because remember what we've got is on the side here, we've got a little hole for a screw there that we need to deal with. And we've got a little screw on the opposite side. Obviously we don't want to do them first because we need that flexibility to be able to get our front bulkheads in. So grab your bulkheads and your gimbal, and then slide your gimbal front bulkhead in place, lift the front up, and that should slot in place. Okay. And then basically what we then want to do is get your side bulkheads. You just want to kind of lever them into their location as well. And they of course snap side on to the front bulkhead. So that's one side, like so. And then the other side. Like so, and that is everything snapped down as it should be. So at this point your best bet is to now get your gimbal screws, those are the little screws there, and let's just pop them in there, and that's just going to seal the bulkhead down in the central position. So you don't have to do them fully tight if you don't want to. One. But this will at least pinch down the frame enough that you should be able to move it around a little bit without things popping out. Okay, so what I suggest you now do is the lower holes. So if I just pick it up carefully, these holes here, we now want to do these ones. So we grab a little encapsulating nut, put it in the right way round, make sure everything's snapped together, grab a bolt, pop the bolt in there and tighten away. Okay, so that's nice and tight. Right, so now we've just got to go around the rest of them, but before we do that, let's just deal with these two top ones, so we are then in a position where the frame is all put together as it should be. So to deal with those top ones, all we're going to do is we're just going to move everything sideways slightly, get the cables out of the way, get our encapsulating nut, and pop it into its corresponding hole. A little bit fiddly. Get our bolt. And screw it down. One side done, move everything gently across. And that one's done there. So now let's just finish up the rest of them. Okay, so now we have all of our screws done up, our frames together, our bulkheads all on, our gimbal is mounted, everything is there apart from basically this floating sort of frame on the top here. The other things you've got to make sure is that we've got things like your GPS need to be connected, so that's this little cable hanging out here, so we just need to turn it on its side now, a little bit fiddly, and we just need to get that tucked down and in place and seated. Not easy to see on camera, unfortunately. Okay. There we go. So that's now in place in there. So that's all done. We've got all of our cables now connected. Everything is where it should be. And now what we want to make sure is that nothing's getting snagged, nothing's getting squashed or anything like that. So for example, we've got this GPS cable. We want to try and make sure it's on the inside of this rubber sphere, like so. And we just want to make sure that these spheres aren't sitting on any of the cables or anything like that. So got a clean view there. Obviously I've got my power outputs for the V2, for the PMUv2, which I still need to connect up, but that's fine, they're in a place which is fine, and basically this wire is going to go across the top of the frame and it's going to connect to those for the PMUv2. Okay, battery is going to be in here, obviously, that's going to be there, so we're pretty much good to go now with these rubber spheres. So now you've just got to do the somewhat arduous task of mounting all of these little spheres into the corresponding holes, and you've just got to push them through. So basically your best bet is to use something like this, fairly blunt object, and then you just got to work your way around each one and push them into the various holes. Not very easy for me to show you on camera, so I'm just going to crack on and do that, and once we're there, we're then in a position where we're pretty much good to go to mount the motors and finish up. So that is them all in place. So as you can see, I now have all of those in. Chances are, if you're at this point in the video, you'd probably been screaming, shouting, swearing about getting these things in. They're not easy. You know, there is no denying there is a tactic to it. I mean, basically the way that I've done that is that I've gone around each one of them and I've just sort of prodded and probed as best I can, just kind of tucking around the edges, so around sort of here. You just push in, you push in, you push in, then you go around the back and you push and you push and you push, and eventually you can just sort of get it through. If you do need to see it, you can see through here. There are little gaps where you can kind of pick the edges around. It's fiddly, there's no denying it, it is fiddly. This is not an easy frame to build. It's not something that beginners want to build. However, look at what you get from doing it. So we now have a NAZA V2 powered quadcopter which can fold out all the way up to this sort of size, and we've got a 2-axis gimbal all mounted to the front of it. Obviously we're not done yet, I've got to mount the motors and everything like that. However, that is the basics of the frame and everything done, nice and neat. We've just got to add the VTX. I've got to do something with my my V2 LED, put that somewhere. Got to plug the PMUv2 in, things like that, and then we'll be in a state where we can at least start talking about the electronics, the OSD, and testing a few things out like that. So we'll carry on. Okay, now we are at the point where we're putting the motors on. Now, I would normally say there's nothing particularly complicated or difficult about putting the motors on. However, there are some critical things that you need to bear in mind when doing this. Number one, I'm using the DJI E300 kit. They come with this nice little pot which has pots of screws, heat shrink, stuff like that. One thing that a lot of people make the mistake of not realising is that you do get different size screws. You get some little 2.5 screws here which won't fit the motors. You then get M3 and M3. One of the most critically important things to bear in mind is the size of these screws. What I'll do is I'll hold them in front of the camera now. Okay, so what we have here from left to right, left is the 2.5 which we're not going to be using. Middle is an M3 screw, and the right hand side is an M3 screw. Now, the most important thing to bear in mind here is that that right hand screw is long, and it is so long that you may find that if you use the long screw, when you actually put it onto the XuGong, the problem that you're going to have is that when it goes through the motor arm, which it will go through here, it goes through the motor arm, it goes into the motor, but if you're not careful, you can actually find that if the windings aren't perfectly tight underneath, it can actually hit the windings. Likewise, there's some heat shrink in here where the wires come in, and actually where the wires attach to the windings, and in the past I've actually, using too long a screw, actually gone into those windings, screws your motor up, wrecks it, absolutely non-repairable. You just have to chuck it in the bin. So please, please, please don't use the long one that is in the kit. Use the small M3 screw. I can't stress that enough. You may find you have no problems with the long ones whatsoever. However, like I say, I've certainly experienced on some of the older motors where it went through a little bit too far. The XuGong used to come with some spacers for that. The other thing to bear in mind is that all of these motors have this little circlip. Now, the XuGong holes on the arms are specifically designed to actually go around that circlip. So when the circlip's in place, basically that circlip will rotate. Obviously it's upside down, but that circlip will rotate freely inside that hole. If you use anything other than the DJI motors, you need to be very careful with that circlip. It's mentioned in the manual, in fact, that the Tiger Air 350s, if you buy them off the shelf, not directly from ImmersionRC, the circlip has some kind of jagged edges on it, and it's not actually designed to fit in the holes in this. Obviously what you can find is you can end up putting everything together and all of a sudden your motors don't turn, or they snag, or they scrape. It's not going to be good for it. So please, please, please make sure that you dry fit first of all the screws, and then second of all you dry fit and just try the circlip to make sure that you get a free, easy rotation of the motors. If you don't do either of those, that's going to be your first pitfall. You're going to find that you're going to have problems with it. Also, if you have use the longer screws and you feel that there may be damage, just have a look inside all of these holes. Kind of hard to see on camera here, but just make sure there's nothing torn up or ripped in there. Give them a test, make sure you're happy with them. Last thing you want to do on a quadcopter is have a motor fail on you in flight, because there's no recovering from it. You will crash. So that's just the little pre-warnings. With that said, I'm going to be using the short screws and I'm going to crack on and fit all of the motors. Other thing to bear in mind, of course, is that nowadays, fortunately, we do get with these E300 kit, we get counterclockwise and a clockwise rotating motor, which means we want to have a clockwise motor here, a clockwise motor here, we want to have counterclockwise here and here. So make sure you've got the right motor. How do you know? Well, there's a little arrow and it tells you which way it spins. So we know this is a clockwise spinning motor, so this one's going to go here, clockwise here, counterclockwise, counterclockwise. And with that I will crack on and get them fitted. Okay, so that's all the motors fitted. Again, let's just have a look at that circlip in the middle there. Make sure that it's not actually hitting. Smooth running, no hitting. This one here, same thing. No hitting. You'll know if they do. And with the DJI motors, it shouldn't be a problem. Okay, so that's all smooth. You won't know if you've drilled too far, if you did use the longer bolts, you won't know that you've drilled too far into the windings until you actually power the thing on. The surefire way of knowing it, if it is dead, is that basically it will just start twitching, the motor will start twitching, or it will not spin up consistently. And if that's the case, then like I say, unfortunately, by that point, there's really no easy way of coming back. It's really going to be a case of you're going to have to replace the motor. So hopefully you heeded the warning and that doesn't happen. And right, okay, so now we're going to move on and we're just going to fit all of the extension wires to the ESCs. Okay, so that is everything all done up now. ESCs are all done, and we just want to make sure to see if we can fold everything in without anything snagging. So we've got one motor in there, that one will slide in there, there's one in here, and there we go. So now we have a nicely folded up quadcopter, and we're pretty much good to go with the power. The only other things that we've got to do now, we've just got to connect our gimbal cable, nice and simple, goes into the front there. Obviously we're also going to need to connect the GoPro, but we'll grab the GoPro cable and we'll put that in. And you'll see also I have actually connected my PMUv2 into my bullet connectors over here, just kind of loosely put them over there at the moment. The other thing we've got to do, of course, we've got to fit the EzUHF receiver, so that's going to be the final part of the plan, and the video transmitter. Okay, so now we're going to fit the video transmitter. Now the suggested location for this is just inside this little slot here. That's where I'm going to put it. You can obviously choose to put it in other places, have it facing other directions. There's a couple of things that you need to bear in mind if you do it this way, but I'm going to go with this. So basically I'm going to slide this through here, and then what I'm going to do is I'm going to use these holes, I'm going to put some cable ties and kind of reverse wrap them around there. It's going to be a bit fiddly because it's something that would have been better to do with this little side bulkhead off. Okay, so we've now got that transmitter nice and firmly in place there. Just tighten it a little bit more. And then it's just a case of taking the power in there, and video in there. Nice and neat. Okay, so then that leaves the front available for our antenna. Now if you're using an EmmersionRC Spiro net, then obviously you've got the option of bending it into 90 degrees. Obviously you don't want it facing forward because it's going to get in the way of the gimbal. What I would advise though long term, while you can get away with that, is to get yourself some of these 90 degree angle SMA connect. You want to make sure it is an SMA, not a reverse polarity SMA. The one that I'm actually holding is reverse polarity. It doesn't have the pin inside there. The reason being that I've used all of my ones. So you want the pin in the big bit, you want a pin, no pin in the top bit. But anyway, just for the purposes of showing you what it then looks like, you'll then be able to screw it in place there. And that's just going to make things a lot easier when it comes to actually moving things about, because you'll be able to now grab your antenna and screw it down directly onto the top of it. One thing you do need to make sure, if you're going to use this way and if you're going to put it in this location, is you want to make sure that there is no way that the wind or anything is going to actually flop this down, because as you can imagine, if there's a prop on here, you're going to have slice and dice, you're going to have all sorts of horrible things happening. So it may be a case of, if you do it, you actually use a cable tie or something just to get it into a secure location so it's not going to move about too much. There are alternative places that you could put it. Like I say, it's really a personal preference as to where you want to put it, and if you're using 2.4 gig, then it's suggested that you don't actually put it in this location, or 1.3 gig for that matter, as the gimbal IMUs can start causing problems. So just think about where you want to put it. Anyway, I'm putting it in the stock location because I'm using 5.8, so that is now in place there, and I will make sure that there's no way of that falling sideways when I actually go flying. Final part of the electronics, of course, is the receiver. So I am going to be using the ImmersionRC EzUHF 8-channel diversity receiver. The idea is to kind of put it at the back here. Obviously, again, it's all personal preference. You could put it here. What you've got to bear in mind, of course, is that these antennae, they are quite long. You need to make sure that they're not going to get in the propellers as well. So you could put it this way round, so that it's maybe a little bit more out of the way. Personally, I'm going to put it this way round, and I'm just going to have them lying down at a flat kind of angle here. I can put one at 90 degrees, so I've got proper diversity if needs be. Personally, I'm going to be mounting it. You could just mount it with a Velcro strap or a cable tie around some of the inner caging here. I'm going to be using my little 3D designed part that I made, which literally just houses it nice and snug and slots together. Friction fit to begin with, but then what that allows me to do is grab my Velcro strap, put it through one side, pull it down, and that's going to go through this hole here, then through that and out that. And then slide it up through that tab. Fold the Velcro over and lock it down, and as you can see, it's now not going anywhere. And then of course the other thing we've got to do, we take our servo wire, ground at the top, and we plug it into channel 1, and we now have all of our electronics where we want them to be. Okay, so as you can see in front of me, I have a very neat little bundle. Everything is all now done. There's only a few things that you didn't see me do, so I'll just unfold it so you can see those. So we'll fold this one out here, this one out here, this one out here, and this one out here. Now the things you didn't see me do, my GPS mount, so this is my flip up mount, which is screwed into one of the actual frame screw holes as mentioned earlier. Screw that down there, so as you can see I've just bundled the wire around it, it's a little bit unneat. I've also fitted my Hero 4 to the gimbal. This is actually using one of my own mounts, which uses a rubber band, but also allows you to fit the protective lens filter because it's very, very flat on the front of it. Details on my Shapeway shop if you want to see that, as is my EzUHF holder, as is my NAZA V2 holder, which I've managed to actually fit onto this front bulkhead, and I've just put a cable tie around it basically, and that all stays in place nice and firm. So that's about it really. All I would say is you now start watching some photos of the frame in its finished state. If you're watching this and you're about to start building, again, go back through this video, make sure you do it in an order that I suggest I've done it. That is to dry fit the front bulkhead with the gimbal and then remove it, thus allowing you the ability to get to the front of the NAZA so you can actually do your ESCs. I found that, compared to 2 or 3 different ways, definitely the best way of doing it. There are other ways of doing it, and ImmersionRC themselves are sort of hashing out the best way to do it before kind of finalising the manual. They are discussing it with me, so it may be a case of by the time this video's come out and you've seen it that there will be an update on that. But anyway, as you've seen, this does work. It's a little bit fiddly in places, but with a bit of patience you do end up with a really nice, neat product in front of you. So following on from this video, obviously I need to get the electronics sorted. I need to flash the EzUHF with the new firmware, which is going to allow me to open up all the joys of the PDB board. Being that I'm in the UK, a question that I'm going to be asking of Immersion is what they're going to do about the UK version of the firmware, or whether or not the 1.5 has the ability of actually doing that. We'll see. And other than that, it's really a case of just getting it up there and doing some flying with it. So once I'm in a position to do that, I'll probably do another video. I'll probably do a full review of it, and we'll go from there.